Alright everybody, welcome to another Robolink tutorial. So today we're going to be programming the crab robot. So, just quick disclaimer, if you haven't looked at our other tutorials about how to use components, I recommend that you go back and watch them, since we're not going to be going over how to use them. So, with that out of the way, we're going to start programming. So real quick, the crab robot is basically a robot that, depending on which sensor you touch, the robot's gonna do a specific action. So if you touch the left or right sensor, they're going to move in the opposite direction from the sensor you touch. If you touch the middle sensor, it's going to try to move in both directions at once. It's going to go left and then right. So the first thing we're going to include is our Smart Inventor.h library so that we can use our motors, since that's going to be heavily used in this program. We're actually going to make two global variables, or key global variables, at first. The first one is speed, and we're going to set it to 80 because we only have one motor. We want to give it enough power that's going to be able to move. So 80 should be a pretty good speed for our motors. The next global variable is going to be our offset. So this offset has to do with the sensors. Because we're using the three top sensors, we want to make sure that um, we trigger the sensor when we block them, and we don't want to hard code a number, so we're gonna do a calibration in our setup. So the offset is gonna help us get a nice number, so for our default that we'll go over and set up. We're also going to make three other variables. We're going to make left default, center default, right default. So in this variables, we're going to save what the sensor sees when there's nothing in front of it. And we're actually going to subtract that amount by 50, the offset. And that's going to make sure that whenever we put our finger in front of the sensor, we definitely get a reaction from our robot. So in our setup loop, we're gonna have a few things in it. So we're gonna set up our motors. So we're gonna make a call to um, Smart Inventor motor use, and we're gonna set up our pins for our LEDs. So LEDs help us distinguish kind of what's happening visually with a robot. So we're gonna use them in this case too. Now we're gonna use it on this robot specifically to simulate kind of like the eyes of the crab. Um, if you look closely, you will notice that I don't have pins 14 or 16. There's no particular reason why not to include it. I didn't include them because I don't actually code them. If you want to code them all, there's no problem with that. It's just more time spent on that, on setting up pins and everything. Now, this part is kind of long, so I'll go over. We're gonna set our default for each of our sensors. We're gonna set that number. We're gonna call this function called SmartInventor.sensor calibration. And then you feed it in what sensor you're talking about. So for this one, we're calling A0, which is equivalent to the left sensor. So what calibration does is it reads a bunch of you have your sensor free, looking at nothing, blocking the sensor, and this function will call to see what number is there a lot of times, and then it's gonna take the average of those numbers and it's gonna set that as the default, and that's what it's gonna be returned in this function. Then we're gonna take the number, we're gonna subtract the offset, and we're gonna assign it to the default variable. So we're gonna do that for each left default, center default, and right default. And then this is gonna allow us to make sure that when we put our finger, we definitely will see a difference from what it usually sees. If we try to hard code our statements later on to have a number that we're actually looking for, we can run the risk of not getting that number because the sensitivity of our sensors is different than what we expected. So doing this in the beginning will allow us to be able to run our robot in different circumstances and almost always get a result. One quick disclaimer with this is do not put your finger in the sensor while it's doing this calibration, because you're gonna cause it to set the default at a lower number than it should be, and then the robot will always trigger on that instance.